All right, in number 27, they're asking you to verify a little formula that they've come up with here, that the definite integral from 0 to x of the absolute value of t dt is equal to this expression here, 1/2 times x times the absolute value of x. And they gave you a little hint here on problem number 27. Let me read this here, which was to consider x is greater than or equal to 0, and then x is less than or equal to 0 separately. So let's kind of look at two different cases. The first one right here, what happens if x is greater than or equal to 0? So that would mean that we're starting this integral at 0 and ending at some value of x, which is going to be positive. So an integral that starts here and ends over here somewhere. So that's going to create a triangular region like this that is going to be above the x-axis. So in that case, all right, let me put a little colon right here. The integral from 0 to x of the absolute value of t dt, well, guys, it's the area above the x-axis of this region here, which would be 1/2 times your base, which is x, times your height, which in an absolute value graph, this is really the line y equals x, is going to be x as well. So it's 1/2 times x times x. Now, any one of us would look at that and say, ooh, that's going to be a 1/2 x squared, which it certainly is, but I got a feeling we might need that expression in just a minute. That's probably the easier part. The second part here is what happens when x is less than or equal to 0. That means that now we're considering some negative value over here for x. So we're looking at this region right here, but what I notice right away then, guys, is we'd be taking the integral from 0 to x of the absolute value of t dt. Let's see what we've got. Now, in this case here, everybody, the weird thing is that since x is a negative number, that means that your upper limit of integration is actually smaller than your lower limit of integration. Like, for example, if x were -4, we'd be looking at an integral from 0 to -4, and that's not the way we like it. We like it better with the larger number on top and the smaller number on bottom. So what would we do? I would change that to the opposite now of the integral from x on the bottom to 0 on the top of the absolute value of t dt. And what would happen now? We're talking about the area of this triangular region, but there's this negative out in front, guys. So it would be the opposite of 1/2 times a base right here of whatever your x value is. There you go. And your height would end up being, ooh, that's a little weird now, the opposite of x. Because x is actually a negative number, so the height would be -x right there. So -x is going to go there for the height. And that's going to become 1/2 times x, and two negatives is going to make that a 1/2 x squared as well. So that's a little bit interesting. That's what would happen there in a case where if x were negative, we'd get that same expression then twice. So I'm curious then, why did they say that this was going to equal 1/2 times x times the absolute value of x and not just 1/2 times x squared? Okay, so that's a little bit interesting there. In that case then, guys, let's take a look. So I guess what we could kind of do to verify this would be to maybe take a look at their expression right here and see if it works when x is positive, see if it works when x is negative. So for example, let me just throw something out right here. If x were 2, we'd be looking at a region starting at 0, ending here at 2. So it would be this area, and its area would be 1/2 times a base of 2 and a height of 2. And so 1/2 times 2 is going to be 2. This formula works there. 1/2 times 2 times the absolute value of 2 is going to get you the same result. But if x were -2, all right, what would happen then? Well, if x were -2, we'd be doing an integral from 0 to -2, which would be the opposite of the integral from -2 to 0 of that function right there, absolute value of t dt. So that would give you then the opposite of a base of 2 and a height of 2 as well. So then, and I forgot my 1/2 there. Sorry. So that would end up then with a value of -2, which is what should happen there, guys, because our limits would be backwards in that case. And I think that's the key. The issue with just saying that the answer is 1/2 x squared is that that answer would always be positive. But if your limits are backwards, if you have a smaller number on top and a greater number on bottom, that answer does have the potential to be negative, which this answer here does. If x were a negative number, this would be 1/2 times a negative number times the absolute value of that negative, which would be positive, and you would end up with the negative answer that you were looking for. So even though it was tempting to say the answer was 1/2 x squared in both cases, that answer would always be positive. This is a variation on that allows for a negative answer if x is negative. And if x were positive, this would still be positive as well. So number 27 is kind of a tricky problem, but hopefully we learned something by that in going through that one.